Cookbook for the Universe 8.8 Unifying Forces Across Scales, Relative Gravity's Revolutionary Framework. Relative gravity, or G, unveils a groundbreaking approach to understanding the universe by unifying the four fundamental forces: gravity, electromagnetism, the weak nuclear force, and the strong nuclear force into a cohesive framework under the concept of relative force RF. By harmonizing these forces across vastly different scales, RG presents a vision of the universe as a unified, interconnected, and dynamic system. 8.8.1 Expressions of Radiative Dynamics. Forces as radiative phenomena. RG conceptualizes each of the four forces as expressions of radiative dynamics, meaning that forces emerge from and evolve through interactions with time, energy, and spatial dimensions. Temporal evolution. Forces are not static. They evolve iteratively across time and adapt to the dimensions in which they operate. This dynamic nature aligns with the delta phenomenon, where abstraction, synthesis, and replication govern transformations across scales. Polymorphic behavior. Forces exhibit polymorphism, adapting their expressions based on the context of their interactions, whether at subatomic scales or cosmic expanses. 8.8.2 Integration of quantum mechanics and relativity. Coexistence of probabilistic and deterministic models. RG bridges the gap between quantum mechanics' probabilistic framework and relativity's deterministic nature, allowing these two seemingly incompatible paradigms to coexist seamlessly. Quantum gravity. While gravity is weak at atomic scales, RG integrates it with quantum phenomena, offering potential insights into the elusive theory of quantum gravity by treating gravity as a relational dynamic influenced by normalized energy and time, e.t. energy-time continuum. By viewing forces as dynamic and interconnected through the dimension of time, RG provides a framework where quantum uncertainty and relativistic causality overlap harmoniously. 8.8.3 Gravitational fields and subatomic scales. A. Gravity at atomic scales. In RG, gravitational forces, though subtle at the quantum level, play a stabilizing role alongside electromagnetic and nuclear forces. Example: electron orbits and atomic stability may involve gravitational fields as a complementary force, mediated by relative equilibrium. By Orion Carl Daly 1. Aka, Essay on Relative Gravity to describe the mechanics of the universe. B. Unified dynamics of particles. Particles are treated as dynamic manifolds that radiate gravitational, electromagnetic, and nuclear forces. Their interactions and stability arise from a shared framework of relative force. 8.8.4 Cosmic scale applications. A. Gravitational lensing. RG explains gravitational lensing as a manifestation of interconnected fields where light waves traverse spacetime curvature shaped by overlapping energy densities, e.t. at cosmic scales. The framework highlights how light interacts with the dynamic resonance fields of massive bodies like black holes. B. Dark matter halos. RG provides an explanation for the structure and behavior of dark matter halos. Impedance modeled as antimatter-like resistance balances gravitational fields, preventing rapid collapse and sustaining cosmic structures. C. Galaxy distribution. The relative equilibrium of forces determines galaxy formation and distribution. RG predicts a dynamic, cyclic interplay of gravitational forces and energy fields that results in the observed clustering and filamentary structures. 8.8.5 Relative force as the common thread. A. Definition. Relative force normalizes all fundamental forces, expressing them as context-dependent manifestations of energy and time relationships. B. Resonance and superposition. RG employs concepts like harmonic resonance and superposition to describe how forces interact and adapt. This allows gravitational, electromagnetic, strong, and weak forces to align under a single mathematical framework. C. Implications for future research. Quantum gravity. RG's unified approach could help uncover the mechanisms underlying quantum gravity, resolving long-standing theoretical challenges. Dark matter and energy. RG offers tools for modeling the elusive interactions of dark matter and dark energy, advancing our understanding of their roles in cosmic evolution. By Orion Carl Daly 2. Cookbook for the Universe. Technological applications. By conceptualizing forces as radiative and harmonic, RG may inspire innovations in energy systems, quantum computing, and propulsion technologies. 8.8.6 Relative gravity's ability to unify the four fundamental forces. Relative gravity's ability to unify the four fundamental forces under the concept of relative force marks a profound step forward in theoretical physics. By integrating quantum mechanics and relativity, RG reshapes our understanding of the universe across scales, providing a dynamic framework for exploring the interconnected nature of all phenomena. This unified vision not only deepens our grasp of the cosmos, but also opens new pathways for scientific discovery and technological advancement. 8.9 Beyond Newtonian, Einstein, and nebular models. Acknowledged are the substantial contributions of Newton, Kepler, and Einstein in defining gravity and suggests that relative gravity extends their work by offering a unified, abstract framework. For RG, gravity is described as not only an attraction, but also a repulsion relative to contextual relationships, from particles to galaxies. Feature nebular theory Einstein's 2D relative gravity, RG. Basis material accretion spacetime curvature relational dynamics. Temperature and harmonic resonance and orbital placement gravitational wells angular momentum relative equilibrium. Dimension static 3D simplified 2D adaptive 3D. Dynamic limited to mass and largely omitted interaction space. Precise but 2D predictive power general trends visualization. 8.9.1 Nebular theory and orbital placement. Includes energy, time, and superposition. Comprehensive across micro and macro scales. The nebular theory suggests that the solar system formed from a rotating cloud of gas and dust. Larger bodies, like gas giants, are positioned further from the sun because temperature gradient, cooler regions at greater distances allowed gas giants to form by accreting lighter elements like hydrogen and helium. Angular momentum distribution. The conservation of angular momentum caused heavier materials to clump closer to the sun, while lighter elements were pushed outward. While nebular theory accounts for general trends in planetary placement, it lacks a dynamic framework to explain. Orbital resonance. Why certain planetary orbits align harmoniously. By Orion Carl Daly 3. Aka, Essay on Relative Gravity to describe the mechanics of the universe. Energy interactions. The continuous exchange of energy and forces between celestial bodies. 8.9.2.1 Einstein's 2D model. Einstein's general relativity describes gravity as the warping of spacetime by mass. The familiar 2D visual rubber sheet with a heavy object creating a depression illustrates curved space. Planets follow curved paths around the sun due to the distortion of spacetime. Gravitational attraction. Objects with greater mass create deeper wells, drawing smaller bodies toward them. However, Einstein's model is limited when visualizing 3D dynamics. In other words, the actual three-dimensional nature of the solar system. 8.9.3 Relative gravity's perspective. Relative gravity provides a 3D framework where the solar system's dynamics are governed by relative mass, harmonic resonance, and superposition, with URF and Re central to its explanation. The idea of gravity as a radiated field is not new. It is a conceptual extension of gravitational waves in general relativity, where ripples in space-time propagate outward from moving masses. RG views gravity not only as a warping of space-time, but also as a radiated field, analogous to electromagnetic fields around charged bodies, where gravitational radiation could be emitted by objects with mass. The harmonic mean described in section 10 acts as the universal bridge between microcosmic and macrocosmic phenomena. By Orion Carl Daly 4. Cookbook for the Universe at the Galactic Scale. RG conceptualizes galaxies as dynamic networks where black holes serve as nodes of gravitational resonance. Superposition and harmonic resonance supports the role of cumulative and relational forces in maintaining orbital stability. Black holes are not isolated entities but active participants in a cosmic web, exchanging energy and information through harmonic interactions. These interactions weave galaxies together into a greater structure, where alternating currents of energy resonate across vast distances. This perspective aligns with the idea of a universal harmonic mean, demonstrating how the same principles that govern atomic particles also sustain galactic threads and their intricate connections. At cosmic scales, RG explains phenomena like gravitational lensing, the structure of dark matter halos, and the distribution of galaxies through its principles of interconnected fields and equilibrium states. For our planet Earth, like electromagnetism, gravity's radiation demonstrates a current that is considered more spread out than the strong and the weak which are on the molecular level. The latter could be considered the modulated equivalent of a compressed spatial body at a higher voltage based on impedance, that is, besides to suit the density of subatomic particle assembly, which is in the above case as Earth is considered here their basis in the first place. But in an accumulative manner, you have gravity from an orbital body. 8.10 Relative force, unified forces through polymorphism by Orion Carl Daly 5. Aka, Essay on Relative Gravity to describe the mechanics of the universe. Relative force RF introduces a revolutionary framework to unify the four fundamental forces: gravity, electromagnetism, strong nuclear and weak nuclear, as polymorphic expressions of a shared underlying property. This paradigm positions forces not as isolated entities, but as interdependent, context-dependent manifestations of a universal spectrum of energy and symmetry. 8.10.1 Symmetry and differentiation of forces. Forces as polymorphic entities. Each force exhibits unique characteristics based on the context in which it manifests: space, time, or matter. Electromagnetic force governs charged particle interactions such as atomic bonding and light propagation. Strong nuclear force, responsible for the cohesion of atomic nuclei operating on subatomic scales. Weak nuclear force drives particle decay in processes like nuclear fusion in stars. Gravitational force shapes the universe's large-scale structure from planetary systems to galaxy clusters. Shared symmetry. Despite their differences, the forces share a symmetry akin to a spectrum of light. Just as light splits into distinct wavelengths colors, the four forces represent unique expressions of a unified phenomenon, differentiated by their interaction with space, time, and matter. By Orion Carl Daly 6. Cookbook for the Universe 8.10.2 The Four Forces as a Spectrum. A. Analogy of light. White light, when dispersed, reveals its spectrum of colors, each a unique wavelength yet inherently interconnected. Similarly, RF treats the four forces as part of a continuous spectrum, their unique wavelengths dictated by their interaction contexts. B. Interdependence. The forces blend and coexist in the universe, interacting dynamically across scales. Gravity and electromagnetism, for instance, govern celestial mechanics, while nuclear forces sustain atomic stability. This interplay reflects the fundamental interconnectivity proposed by RF. 8.10.3 Example. A drop of water in space. A. Demonstration of unified forces. A single drop of water in space exemplifies the unification of forces. Gravity maintains the drop's cohesion and interaction with surrounding bodies. Electromagnetic forces sustain molecular bonds within the water. Strong nuclear force ensures the stability of atomic nuclei. Weak nuclear force drives internal energy dynamics, such as radioactive decay if isotopes are present. B. Dynamic interplay. These forces blend to define the drop's properties, energy state, and behavior in space-time. The RF framework emphasizes that the drop is not simply governed by isolated forces, but by their collective influence, shaping its evolution and interactions. 8.10.4 The unified concept of force. A. Integration across scales. RF redefines the four forces as interconnected expressions of a unified energy spectrum. Gravity and quantum mechanics. By contextualizing gravitational interactions alongside nuclear and electromagnetic forces, RF bridges macrocosmic and quantum phenomena. Dynamic systems. Objects, particles, and galaxies operate as part of an integrated system where forces dynamically adapt and interact. B. Evolution of the universe. By Orion Carl Daly 7. Aka, Essay on Relative Gravity to describe the mechanics of the universe. This unified perspective shapes the evolution of matter and energy, explaining cosmic phenomena from the Big Bang to the formation of galaxies. Forces blend in ways that maintain harmony and drive progression across the universe's history. 8.10.5 Visualization. The relative force prism. The accompanying diagram captures RF's essence. The triangulus paradigm represents the shared foundation of universal forces. The spectrum of differentiated forces depicts how the universal property of force manifests as gravity, electromagnetism, and nuclear forces. Interaction and interdependence demonstrates that no force operates in isolation, but within a shared, dynamic framework. 8.10.6 Relative force provides a transformative lens through which to view the fundamental forces of nature. By recognizing these forces as interrelated expressions of a shared property, RF unifies quantum mechanics, relativity, and classical physics under a single, cohesive paradigm. This concept not only deepens our understanding of the universe's structure, but also offers a robust framework for future explorations into the nature of reality itself. 8.11 Uniform Relative Force URF. By Orion Carl Daly 8. Cookbook for the Universe and the Theory of Relative Gravity. The concept of uniform relative force URF emerges as a unifying framework to explain how particles, matter, and even galaxies are held together. Akin to how a droplet of water demonstrates its cohesive nature in the vacuum of space, the URF serves as a manifold that binds the universe's fundamental forces gravitational, electromagnetic, strong nuclear, and weak nuclear into a cohesive, interconnected model. This section delves into the theoretical underpinnings and implications of URF, illustrated by its mathematical formulations and analogies. 8.11.1 The manifold nature of URF. URF is conceptualized as a dynamic, abstract manifold where the four forces interact as polymorphic expressions of a unified principle. These forces are differentiated by their spatial and temporal contexts, but remain intrinsically connected through their shared relative force properties. Uniform relative force is referred to in the essay as Earth, where its area as a body is described as 4 pi r2 square arete or radius in length. Energy time. Where r. Frequency of the radius. E. Amplitude of the radius. T. Relative time of the radius. This formula illustrates how the area of force is a function of frequency, amplitude, and relative time, emphasizing the dynamic oscillatory nature of forces at various scales. 8.11.2 Analogies with Ohm's law. URF can be likened to voltage in electrical theory, with the following parallels. Voltage V represents the potential energy or force within a system. Current I, the flow of energy or force through manifolds. Resistance and impedance are the contextual factors, for example dark matter, that regulate the flow of energy and forces. This analogy positions URF as the universal potential driving interactions at atomic, planetary, and cosmic scales. Impedance acts as the limiting factor, much like. By Orion Carl Daly 9. Aka, Essay on Relative Gravity to describe the mechanics of the universe. Resistance in an electrical circuit, shaping how forces manifest in different environments. 8.11.3 Dark matter as gravitational impedance. Dark matter, often elusive and enigmatic, is reimagined as a gravitational impedance within the URF framework. Its role includes a. Balancing forces, prevents runaway gravitational collapse or uncontrolled expansion by modulating gravitational waves. b. Confining oscillations, limits the oscillatory range of forces, effectively shaping the observable universe. c. Galactic stability, ensures the cohesion of galaxies despite their vast scales and dynamic interactions. This perspective positions dark matter as a crucial component of URF, providing the resistance necessary for cosmic structures to maintain equilibrium. 8.11.4 Applications to neutron stars and black holes. The concept of URF extends to extreme environments like neutron stars and black holes. A. Neutron stars. Immense pressure compresses matter into ultra-dense forms, demonstrating URF's role in balancing nuclear and gravitational forces. B. Black holes. Dark matter's impedance around black holes constrains gravitational oscillations, shaping event horizons and influencing accretion dynamics. URF provides a lens to understand the interplay of forces in these extreme contexts, offering insights into the behavior of matter under immense pressure and density. 8.11.5 Contextual variability. URF's expression depends on the contextual impedance of the environment. For example, in gravitational fields, impedance corresponds to spacetime curvature around massive objects. In electromagnetism, impedance relates to the medium through which electric and magnetic fields propagate. This variability ensures that URF adapts to different scales and phenomena while maintaining its unifying principles. By Orion Carl Daly 10. Cookbook for the Universe. 8.11.6 Unification of the four fundamental forces. URF provides a pathway to unify the four fundamental forces, viewing them as unique manifestations of the same underlying principle. Key insights include a. Electromagnetic force governs atomic and molecular interactions mediated by photons. b. Gravitational force shapes large-scale structures mediated by gravitons and quantum gravity models. c. Strong nuclear force binds protons and neutrons mediated by gluons. d. Weak nuclear force drives radioactive decay and subatomic processes mediated by W and Z bosons. These forces, while distinct in their individual behaviors, share a fundamental symmetry under URF. Their differentiation arises from their spatial-temporal contexts and the impedance within their respective environments. 8.11.7 Implications and future directions. The URF model bridges gaps between classical mechanics, relativity, and quantum mechanics by providing a cohesive framework for understanding particle interactions, cosmic dynamics, and dark matter, offering mathematical tools to model forces across scales, from atomic nuclei to galaxies, suggesting pathways for exploring unified field theories and quantum gravity. By reimagining the universe as a dynamic system governed by uniform relative force, this model lays the groundwork for a deeper understanding of the interconnected nature of forces, matter, and energy, shaping the cosmos in both its simplicity and complexity. Section 8.12 Relative Polarity and Distance. By Orion Carl Daly 11. Aka, Essay on Relative Gravity to describe the mechanics of the universe. Relative polarity and relative distance serve as fundamental principles in the framework of relative gravity (RG), offering insights into particle behavior, force interactions, and cosmic phenomena. These principles extend beyond conventional physics, enriching the understanding of the relationships between particles, fields, and larger structures in space. 8.12.1 Conceptual Framework of Relative Polarity. Relative polarity is defined as the comparative property that allows differentiation and interaction among particles and entities. It proposes that particles and subatomic elements behave as manifolds of currents with distinct polarities. More positive entities exhibit higher positivity compared to others in their vicinity. Polarity is not binary but exists on a continuum, allowing for gradations such as more positive or less negative, creating a dynamic spectrum rather than discrete states. This approach connects directly to the behavior of forces, such as the strong and weak nuclear forces, as manifestations of relative polarity. 8.12.2 Applications to Physics. Relative polarity integrates into both classical and quantum physics, providing a cohesive framework for understanding. A. Electric currents. The flow of electrons between positive and negative poles is explained as a result of relative polarity gradients. B. Atomic shells. Different energy states correspond to varying polarity levels, influencing electron placement and bonding interactions. C. Macroscopic and microscopic scales, from celestial bodies to atomic particles. Relative polarity governs interactions and ensures dynamic equilibrium across scales. 8.12.3 Interdisciplinary insights. Relative polarity bridges theoretical physics with observable phenomena. A. Electron flow and polarization. It explains electron movement in circuits and the polarization of atoms, shedding light on molecular bonding and ionization. B. Cosmic phenomena. Offers explanations for galaxy formation, electromagnetic fields, and photon interactions with gravitational fields. By Ryan Carl Daly 12. Cookbook for the Universe. C. Relative distance, a relational property. Building on relative polarity, relative distance defines the spatial and energetic relationships between entities. It suggests that smaller entities maintain closer proximity to larger entities they interact with due to proportional relationships. Larger bodies can maintain interactions at greater distances without compromising equilibrium. 8.12.4 Abstract principle. Relative distance ties directly to concepts of A. Orbital mechanics, explaining why smaller planets remain closer to their suns while gas giants orbit at greater distances. B. Galactic interactions, informing theories of galaxy alignment and gravitational systems. 8.12.5 Relative polarity and force interactions. 8.12.5.1 Strong and weak forces. A. Strong nuclear force. The balance of protons and neutrons in the nucleus is explained as a polarity interaction, where neutrons' neutrality arises from internal polarity balances. B. Weak nuclear force governs beta decay, where shifts in relative polarity transform neutrons into protons and electrons. 8.12.5.2 Polarity as a continuum. This redefinition introduces the idea of a polarity spectrum. Charge gradients redefines how charges interact, allowing for intermediate states rather than binary opposites. Energy states describes how particles and atomic shells interact dynamically within fields, influencing bonding and ionization. 8.12.5.3 Current flow and atomic shell dynamics. Electron flow aligns with polarity gradients, explaining electron movement and molecular bonding. Energy as polarity. Atomic shells are viewed as energy states driven by polarity gradients. Ionization occurs when external forces shift polarity into new configurations. By Ryan Carl Daly 13. Aka, Essay on Relative Gravity to describe the mechanics of the universe. 8.12.5.4 Implications for electrodynamics and cosmology. Superconductivity explains resistance-free electron movement in polarizable environments. Dielectric materials, insights into energy storage and release through polarization. Cosmology, polarity gradients inform theories of galaxy formation and electromagnetic fields in space. 8.12.5.5 Broader implications. 8.12.5.5.1 Unification of forces. Relative polarity may unify the four fundamental forces. Gravity, interpreted as the weakest polarity interaction at cosmic scales. Electromagnetic, strong and weak forces, framed as manifestations of polarity gradients within specific contexts. 8.12.5.5.2 Quantum mechanics and relativity. Quantum superposition reflects unobserved polarity states of particles. Relativity, effects like time dilation, emerge from shifts in polarity as energy states change with velocity or mass. 8.12.6 Relative polarity and distance redefine how particles and entities interact, offering a continuum-based perspective that aligns with existing theories while enabling new explorations. Dynamic gradients govern interactions across scales. Interdisciplinary connections bridge abstract theoretical physics with practical applications. Unified framework integrate forces into a cohesive model, emphasizing symmetry and relational properties. These principles deepen the understanding of the universe's dynamic structure, illustrating how forces and entities evolve through interconnected, context-dependent relationships. By Ryan Carl Daly 14. Cookbook for the Universe. 8.13 Relative distance. Relative distance dictates the equilibrium point between gravitational forces of interacting entities. m1d2 equals m2d1. Relative distance explores the equilibrium points and dynamic relationships between interacting entities, offering a unified framework that scales from subatomic particles to galactic systems. It extends classical mechanics by incorporating relative polarity, redefining how distance and size influence interactions, and providing a deeper understanding of orbital mechanics, magnetic forces, and cosmic structures. 8.1 3.1 Conceptual Framework, Relative Distance and Polarity. Relative distance introduces a distance-dependent polarity gradient that adjusts dynamically based on proximity and mass. Eight point one 3.1 Conceptual Framework, Relative Distance and Polarity. Relative distance introduces a distance-dependent polarity gradient that adjusts dynamically based on proximity and mass. 8.1 3.1.1 Distance-dependent polarity gradients. A smaller entity may exhibit less positive polarity relative to a larger entity it is attracted to, yet it can be more positive than another entity it attracts. Proximity effect. The closer two objects are, the stronger their mutual polarity gradient, amplifying the interaction. By Orion Carl Daly 15. Aka, Essay on Relative Gravity to describe the mechanics of the universe. 8.1 3.1.2 Mass and size effects. Larger objects create more potent polarity gradients, influencing smaller objects across greater distances. This creates a scalable hierarchy from subatomic particles to celestial bodies. 8.1 3.1.3 Context-dependent polarity. Even absolute polarity is not fixed but depends on the size, distance, and interaction of entities within their context. 8.1 3.1.4 Absolute polarity is relative. Even absolute polarity is context-dependent, varying with distance and size of interacting objects. This suggests a scalable hierarchy. Subatomic particles, right arrow molecular structures, right arrow celestial bodies. 8.1 3.2 Applications to orbital dynamics. Relative distance reframes orbital mechanics by integrating polarity gradients. A. Planets and the Sun. Smaller planets orbit closer to the Sun due to their relative polarity gradient, where the Sun's immense mass pulls them into tighter orbits. Larger gas giants, with stronger self-contained polarity fields, stabilize at greater distances, balancing their larger masses in polarity. This interpretation aligns with Kepler's laws but introduces polarity-based reasoning for orbital stability. B. Mutual attraction as polarity balancing. Larger and smaller objects find equilibrium by equalizing their relative polarity gradients, resulting in stable orbits proportional to their mass and distance. By Orion Carl Daly 16. Cookbook for the Universe. 8.1 3.3 Relative Distance in Everyday Physics. A. Magnetic interactions. Large magnets attract smaller ones more strongly at closer distances due to intensified polarity gradients. Two large magnets maintain attraction across greater distances, demonstrating the scalability of polarity gradients. B. Gravitational analogy. Gravitational attraction between two masses can be reframed as a function of relative polarity gradients. Proximity effect. Closer proximity amplifies the gradient, enhancing attraction. Mass effect. Larger masses sustain their influence over longer distances, akin to stronger magnetic fields. 8.1 3.4 Subatomic to cosmic scales. A. Particle differentiation. Subatomic particles, protons, neutrons, and electrons exhibit distinct polarity gradients that define their spatial relationships and stabilize atomic structures. Relative polarity gradients explain why particles maintain specific distances, forming stable nuclei. B. Cosmological dynamics. Smaller galaxies orbit larger ones in tighter patterns, reflecting cosmic scale polarity gradients. Intergalactic interactions can be viewed as manifestations of these gradients, stabilizing galactic clusters. By Orion Carl Daly 17. Aka, Essay on Relative Gravity to describe the mechanics of the universe. 8.1 3.5 Orbital dynamics of gas giants. A. Earth versus gas giants. Gas giants, with larger masses, exhibit stronger self-contained polarity gradients, allowing them to balance at greater distances from the Sun. Earth, being smaller, exists closer to the Sun, where its relative polarity gradient aligns with tighter coupling. B. Resonance and distance. Orbital resonances, e.g., Jupiter and its moons, can be interpreted as polarity balancing at varying distances, ensuring harmony within the system. C. Mutual attraction as polarity balancing. Larger and smaller objects balance their relative distances according to their mass, effectively equalizing their relative polarity gradients. The result, stable orbits proportional to mass and distance. 8.1 3.6 Mathematical representation. Relative polarity distance function. F polarity equals K m1 m2 d2. K, polarity constant, analogous to gravitational or electrostatic constants. m1 m2, masses or polarities of interacting objects. D, relative distance between entities. This formula follows the inverse square law, highlighting how polarity gradients weaken with increasing distance. 8.13.7 Broader implications. A. Unified dynamics, relative distance bridges quantum mechanics, classical physics, and cosmology by integrating polarity gradients and distance into a cohesive framework. B. Further exploration. Investigate photon gravity interactions, where light's behavior under gravitational influence could reveal polarity gradients. Explore subatomic particle behavior under extreme conditions, such as near black holes. Reframe dark matter and dark energy as manifestations of unobserved polarity gradients influencing cosmic dynamics. By Orion Carl Daly 18. Cookbook for the Universe 8.13.8 Relative distance builds on the concept of relative polarity, providing a scalable, dynamic framework that unites phenomena across scales. A. Microscopic scale explains particle interactions and atomic stability through polarity gradients. B. Macroscopic scale offers new perspectives on orbital mechanics and magnetic interactions. C. Cosmic scale illuminates galaxy formation, intergalactic interactions, and the behavior of dark matter. This innovative approach emphasizes the interconnectedness of size, distance, and polarity gradients, revealing deeper insights into the mechanics of the universe and laying the groundwork for future theoretical and experimental explorations. Section 8.14. Synthesis and implications. The integration of relative polarity and relative distance offers a transformative framework for understanding the mechanics of interaction across the full spectrum of physical phenomena, from subatomic particles to galaxies. This synthesis bridges disparate forces and scales, establishing a unified perspective on the underlying principles governing the universe. 8.14.1 Unifying forces across scales. The framework of relative polarity and relative distance unifies the four fundamental forces: gravitational, electromagnetic, strong nuclear, and weak nuclear, by highlighting shared foundational properties such as polarity gradients and distance-dependent interactions. A. Symmetry across forces. These forces, while manifesting differently, are proposed to share intrinsic symmetry through their contextual dependencies on polarity and distance. For example, the strong nuclear force maintains atomic nuclei cohesion through polarity gradients within close distances. The gravitational force governs large-scale structures like planets and galaxies through distance-based polarity gradients. B. Unified framework. This synthesis underscores a scalable continuity where forces adapt dynamically across contexts while adhering to conserved universal principles. By Orion Carl Daly 19. Aka, Essay on Relative Gravity to describe the mechanics of the universe. 8.14.2 Hierarchical models of interaction. The theory's scalability provides a coherent explanation for interactions at multiple levels, linking microcosmic and macrocosmic phenomena. A. Subatomic particles. Relative polarity governs the cohesion and repulsion of particles within atomic structures. Stable atomic shells emerge from balanced polarity gradients, with ionization or bonding occurring when external forces shift these balances. B. Celestial bodies. Relative distance, modulated by polarity gradients, explains orbital stability, interplanetary dynamics, and resonances within planetary systems. For instance, smaller celestial bodies orbit closer to their primary star due to their relative polarity gradients, while larger bodies stabilize at greater distances. 8.14.3 Potential applications. The integration of relative polarity and relative distance opens new avenues for both theoretical advancements and practical applications. A. Quantum systems. The principles can enhance computational modeling of particle interactions, offering new tools to predict behavior in quantum systems such as entanglement or superposition states. Insights into the role of polarity gradients may refine our understanding of particle bonding, decay, and charge distribution. B. Astrophysics. Relative polarity and distance could improve predictive models for celestial phenomena, including planetary orbits, interstellar interactions, and galactic formations. Applications may extend to better understanding gravitational lensing, dark matter distribution, and cosmic resonance phenomena. By Orion Carl Daly 20.